All right, so we have a question here. It says, during a particular summer month, 25 salespeople in a heating and air conditioning firm sold the following number of central air conditioning units. Right, so we have data here. This is ungrouped data. Okay, so they've told us calculate each of the following. Number one, average number of air conditioning units sold. All right, so to get the average number, and we'll need to add up all these numbers. Okay, we add all of them, right? There are 25 of them, right? There are 25 numbers in this data set, right? So since we have 25 numbers in this data set, so n equals 25. N equals 25. N equals 25, right? So we'll look for the formula for the mean. Right, so here is the formula, right? As the formula says, we're going to add up all our values, all right? The summation of x represents all the numbers, all right? We're going to add all of them, and then we're going to divide by the number of numbers in the data set, all right? The number of numbers in the data set, right? And the number of numbers in this data set is 25, all right? All right, so we're going to get to say 3, so say open brackets, 3 plus 6. Someone with a calculator, all right, 3 plus 6 plus 8 plus 9 plus 12 plus 16 plus 18 plus 19 plus 23 plus 27 plus 31 plus 33 plus 87 plus 40 plus 41 plus 44 plus 6 plus 48 plus 52 plus 54 plus 56 plus 59 plus 61 plus 65 plus 67, right? We add all of these and divide by 25. I hope someone had the calculator as I was doing this. Has someone found that value? Has someone found this value when we add all these 25 numbers?
625.
625?
875.
875, all right, divided by 25. What do we get?
35.
35. So that is our mean, all right? That is our mean, x bar, okay? This x bar here, that is our mean, okay? So that is the first one, finding the mean. Right. The next one is the range, which is the easiest. All right. The range is just the highest value subtracted by the lowest value. Range is highest value HL minus lowest and highest. All right. So our highest value in this case is 67. Our lowest value is 3. 7 minus 3 gives us 64. Gives us 64. Right. That is the range. The next is we have to find our median. All right. We have to find our median. Okay. There are many ways we can locate the median. All right. So let's use the 50th percentile to locate our median. Okay, we use the 50th percentile to locate the median. Okay, here's the list of ways we can look for the median. All right, there are 25 data values. We can use this formula here. All right, y n plus 1 over 2, or we can use the measures of position, which is we can use the 50th percentile to locate our median. All right. So, family, which one should we use? This one here with the percentile or this simple one here?
The simple one, please.
Okay. Or we'll use both, maybe. I think we use both so that you can, when you are studying, okay. All right. Okay, so we use the simple one, all right? The simple one is just n plus 1 divided by 2. Okay. We know our n is 25, right? 25 plus 1, all right? Divided by 2, that is 26. 26 divided by 2, that gives us 13. So our median is on the 13th position, all right? Our median is on the 13th position. Using percentiles, all right, we say n plus 1, right? By using the 50th percentile, so p is going to be 50, n plus 1 times p divided by 100, all right? So n is 25 plus 1 times 50 divided by 100, all right? So you say 26 times 50, 26 times 50 divided by 100. 26 times 50 is 1,300, right? 1,300 divided by 100, you get 13.
13.
Yes, so both of them will give you the same 13th position, all right? So we count one, let me just, all right, start 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is our median, 13. All right. That is our median. Okay. Any questions before we move further? All right. So the next was
After the question,
okay.
yes, on the formula where I use the percentile,
Yes.
the P is 50. No problem.
Yes. Yes.
How did you get that? How did you arrive to that 50?
The median is the 50th percentile, all right, of the data set, right? The median is the 50th percentile. Okay, it's
Okay.
yes. Yeah, you just imagine that the whole data set is 100%, and then the middle one will be at 50%. So that's how we did
All right.
it. Yes. So let me just put here. So as you are studying, P 50th percentile. Okay. P equals 50, and that is the median. Equals the median. Right? So even when we come to the interquartile range, right, when we're trying to find the lower and upper quartiles, we use these percentiles to be able to locate them. Okay. Or if you do not want to use the percentiles, all right, as you see, this data has been divided into two equal parts. All right, this part which I've shaded, and this other part here. All right. So you can look at them individually and still use this formula. So we'll come to that when we get there. What was the next part? Median, the standard deviation. All right, the standard deviation. Basically, we're trying to find how far our data points are from the mean, all right, from the average. How far are these points from average? Okay, so there are two ways we can do this. All right, let me just admit someone in. Okay, both ways are very intensive, but we're going to make a table, all right, a two-column table. Make a two-column table. One will be for x and one will be for x squared. All right. Each data value, we're going to square it. Where are the numerals in here? Just hold on. Let me make a proper table. I don't know why these numerical values are coming in this table, but let me just delete them. So this will be a very big operation, right? A big operation. All right, so here we're going to have x, and here we have x squared. All right, so each data value will be squaring it. So we start 3 squared is 9. 6 squared is 36. 8 squared is 64. 9 squared is 81. 12 squared is 144. Okay. Now this is where the calculator is going to come in handy. Right. What is 16 squared?
256.
256. 16. Then 18 squared.
324.
324. 19 squared.
361.
All right. 361. Then we go to 23 squared.
Hello,
Yes.
Mr. Mara.
Yes.
I think me, I'm not.
Okay. Here, what we're
I've
doing.
just joined.
Okay. What we're doing here. All right. We are calculating the variance. Okay, we're calculating the variance. So we've been given ungrouped data. All right, have you seen this data which is here, which I've highlighted? Yes.
Yes.
Yes, we are now here. We're trying to find the variance. Right, the variance, basically we're trying to measure how far each data set is from the mean. Okay, so we're trying to find the variance. So this is the how you calculate for the variance. All right, there are two ways. This is the first way. All right, the first way, right, you are going to get each data value. Right, each of these numbers here, you get all of them and you'll be squaring them. Okay, you get all of them and you square them. Right, are we okay with that? Mrs. 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 NL. Are we okay with that? We are getting each number here in this value of these values. We're getting each of them, and we are squaring them. All right. Then we're going to put them into the formula. We're just trying to calculate the variance. Okay. All right. Can we proceed? 23 squared.
Yes, I can, sir. 529.
5.
29.
529. Okay. All right. The next one is 27 squared.
729.
739. We have the next one.
9. 729, sir. So
Awesome.
9.
Okay. Then the next one is 31 squared.
961.
961. Right. The next one is 33 squared.
1089.
1089. Right. We've now reached the middle point. All right. 37 squared.
1369. 1.
Yeah. 40 squared. This one should be 800. Huh? 800. 16. If I be. Am I correct? 16.
Yes, it's 1.
Okay. 41 squared.
1681.
1581.
16.
Oh, 1681. Okay, 44 squared.
1936.
1936. 46 squared.
2116.
48 squared.
2304.
2304. All right, let's see what number was next after 48. 52 squared.
2704.
2704. All right. We've got the next one. 54 squared. 54 squared.
2916. 2916.
2916. All right. Then after 54 squared, we have 56 squared. That's why I start this.
3136.
3136. And so statistics, you have to be very patient, all right? Especially if they have been given a lot of data values like this, okay? In an exam, do not rush, take your time, right? 56, then 59 squared.
3481.
3481. All right, and then let's see, 61 squared.
3721.
Have I got it correct? 3721.
Yes, correct.
Okay, then we have 65 squared.
4225.
4225. All right, and finally we have 67 squared.
4489. 4489.
4489. So now what's going to happen is we are going to have to add up all these values in the x squared column. Right here already we got our total here was 875. All right, for x, the x values 875. Now these values here, we have to total them up, all of them. All right, all these values, we have to total them up. Okay, so has someone done that? Let me just get the formula. The formula we're going to use. This is the formula we're going to use here. Let me just screenshot the formula, then we can add up together. All right. All right, so yeah. Has anyone added these up? I will add them up together. 9 plus 36 plus 64 plus 81 plus 144 plus 256 plus 324 plus 361 plus 529 plus 729 plus 961 plus 1089 plus 1369 plus 1600 plus 1681 plus 1936 plus 2116 plus 2304 plus 2704 plus 2916 plus 3136 plus, okay, 3136, right, plus 3481 plus 3721 plus 4225 plus 4489. We get 40,261. And is that what everyone is getting? 40,261 is what I am getting. All right. So as this formula,
Excuse me, sir.
yes.
I don't know if we had made the same question is different.
Last time
last week we got last week the last time we had class we got 4,871.
4,871. Okay.
Yes, just confirm on the square root for 61.
61. Okay, let's see. 61 times. We get 3721.
3721. Okay.
Right. Because may have just added this now. This is what I've got. So that's what I'm saying. Has anyone else added them?
Yeah, we can carry on, sir.
Okay. So in this formula, as you can see, all right, 1 over n minus 1, all right, n is with the number of values, all right. So the number of values is 25, so small n equals 25, right? We have 25 numbers, okay. Then they've told us the summation of x squared, which is this 40,261, minus 1 over n times the summation of x, which is 875, and we square this summation. So we'll square 875. Okay, so it's going to be like this. 1 divided by 25 minus 1, right? Open brackets, 40,261 minus 875 squared. All right, let me put this in square root. 875 squared, all right, divided by 25, close brackets. Are we okay with this? Are we okay? Any queries before we do the divisions?
Hello,
Yes.
Mr. Mara.
Yes.
I think on the formula can repeat again.
Okay. On the formula, all right, n, this small letter n represents the number of numbers in the data set, all right? The number of numbers in the data set, or the number of data values in the data set, all right? So if you see in our data set, okay, this is our whole data set here. We have 25 numbers, okay? We have 25 numbers in our data set. So small letter n equals 25, all right? So this is why I've seen the 1 over 25 minus 1, all right? So let me even be highlighting this maybe so that, so n, okay, where there's n, you put 25, okay? So as you can see here also we have another 1 over n, all right? That would be 1 over 25, okay? This summation of x squared, all right, we've put it on the numerator. That's why you have 875 here, right? We've put this summation of x, which is 875. We added up all our data values. We got 875. So that's the summation of x. Remember, x represents each number, all right? So x, the summation of x is 875. Then we have to square it. That's why I find 875 squared. Then this one here, the summation of x squared. It's this column here in our table, right? This column here, right? So the summation of x squared, remember when we added all these values in this column, we got 40,261. Are we okay with that, Mrs. Ena?
Yes.
Okay.
Yeah.
Yeah. So these formulas,
Yes.
okay. So these
So
formulas you do
where
not.
is the 25? Where is the 25 dividing the 875 squared coming from?
Here, this last part of the formula, all right, this last part of the formula here, all right. If we wanted, would have put 1 over 25 times 875 squared, all right. Would have put it like that, but here we've just put this in the numerator. This summation of x squared, we've put it on the numerator.
Okay, so the one doesn't really count because it doesn't change anything.
It doesn't, yes, because when you multiply 1 times 875 squared, you still get 875 squared.
All right, thank you.
All right. So we have 1 over 26, all right, open brackets, 40,261 minus. So what is 875 squared? Oh, 25 minus, that is 24 here. It's 1 over 24. 875 squared. All right. 875 squared. No one has given me a value up to now. 875 squared, that's 760.
700,000.
Mm-hmm.
Okay.
No, you can read it.
765,625.
Divided by 25, right? Divide by 25. Okay. Remember, we are doing paid mass, all right? So before we continue with the operation, we have to first divide this 765,625 by 25. First operation we're going to do, all right? What is 765,625 divided by 25?
30,625.
13,600
30.
or 30,625, all right? Then you now subtract, all right? You say 40,261, 40,261 minus what do you call this? Minus 30,625.
Nine six three six.
9636, right? Is that correct? 9636, 9,636.
Yes.
Divide it by 24.
401.5.
401.5. That's our variance, right? That is our variance. Then to get our standard deviation, we find the square root of this variance, all right? Standard deviation,
Excuse me, sir.
yes.
I think I would like to learn what exactly is variance, just to define it so that I'm able to understand what we're really doing. I understand the numbers and everything, but what is it exactly?
We're just trying to find how far each data set is from the mean. If I use the other formula for the variance, it actually explains that more, because what you'll be doing is you're doing each data value, you subtract it from the mean, then you square it, each data value, then you find the variance. But basically, that's that's the whole basis here, right? How far and spread out the data values are from the mean.
All right, thank you.
So I'll show you the other formula. It's actually shows that whole process where you do x minus x bar, x minus, then you square all of those again, then you find the variance. Okay. Yes. So standard deviation, it's just the square root of the variance, right? So you just find the square root of 401.25. Where is the square root symbol? Okay, let's see which formula has got a square root in it. Right, don't worry, this is not a formula. This is for, that formula is for what you call this, quadratic equations. All right, what is 401.5? What's the square root of 401.5? All right, standard deviation, we just write it as an S.
20.04.
20.04. 20.04. All right. That's the standard deviation. Okay. And then finally, we'll find the first quartile and the third quartile and calculate the interquartile range. So we'll get this information here. All these data values, copy. This part.
Sir,
Yes.
so you mean to find the standard deviation, first we have to find the variance.
Always. You will
Okay.
never be able to find the standard deviation minus the variance. So once a question won't even tell you, won't even need to tell you to find the, once they just see standard deviation, just know that, oh, also variance will be needed. That's question 5. Right, the interquartile range. So basically, we've already got our median, all right, which is Q2, is the middle quartile. Q2 is the middle quartile. Right, so we need to find Q1 and Q3. All right, so to get Q1, which is the lower half, all right, Q1, which is the lower half of the, Q1 separates the lower half of the data into two parts, okay? That's what Q1 does, the lower quarter, to separate the lower half of the data into two parts, all right? here Q2 has divided the whole data into two parts, all right? Then now Q1, this part which I've shaded, which I'm shading here, Q1 is going to divide this lower half of the data again into two parts, all right? That's what the quartiles divide the whole data into four parts. That's what quartiles do. They just divide the data into four parts, all right? So Q1, we can locate Q1's position with percentiles, all right? Q1 is the 25th percentile, right? It is the 25th percentile, right? So we can say n plus 1 times p divided by 100 equals, all right? Remember, we have 25 numbers in this whole data set, so n is 25 plus 1 times p. P is 25, okay? When p is 25 divided by 100, okay? So 25 plus 1, that is 26. 26 times 25, 650. Okay, 650. 650 divided by 100 is found at the 6.5th position. All right. So we say 1, 2. Let me zoom in a bit. 1, 2,
Hello?
3, 4, 5, 6. 6.5. Yes, 6.5 is here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. Yes.
Mr. Mama,
Yes.
I think me, I'm behind.
Okay. Let's see. Let's hear what. Okay. We are finding the interquartile range. Okay. So here, what quartiles do, as I said, quartiles will divide the data into four equal parts. All right. So, all right, the median, which represents Q2, is there. It's going to divide the data into two parts. Okay. Could you please mute your mic? All right. The median divided the data into two equal parts. Okay. Now, the lower quartile, all right, the lower quartile is going to divide the lower half of the data, right? Maybe let me get the lower half of the data, all right, into two equal parts, all right? What I've shaded here is the lower half of the data. Are you able to see? That's the lower half. Okay. The lower quartile will divide this part of the data into two equal parts. So what we're doing here is we are locating the position, all right? We're locating the position of the lower quartile. So to locate the position of the lower quartile, right, this you can use percentiles, all right? Percentiles will enable you to locate the position of these quartiles, all right? Remember, Q2, we located it with the 50th percentile, right? Q1, we're locating it with the 25th percentile, all right? The 25th percentile. So, using the 25th percentile, Have you seen this formula I've used here? Want to locate the position of Q1. For this lower half of the data, which I've shaded now here, this lower half here, or this data here, want to find the middle of this lower half so that we divide it into two parts. Okay. So after we use the formula for the 25th percentile, n plus 1 times p divided by 100, we get 6.5. All right. So 6.5, the position of the lower quartile is the 6.5th position. All right. You come to your data, the lower half. All right. You start 1, 2, 3, 4, 5, 6. Right? So 6.5 is in the middle here, between 16 and 18. Okay? It's in the middle there. All right? It's here in the middle, the 6.5th position. All right? So, all right, we've divided this lower half, let me put it in another color, into two parts. All right? This part here, 1, 2, 3, 4, 5, and this other part here, okay? 1, 2, 3, 4, 5. We have divided the lower half of the data into two equal parts. All right. So to get our Q1, since it's between two numbers, so you say Q1 equals 16 plus 18. You find the average of the two numbers, 16 plus 18 divided by 2. What is 16 plus 18? 34. 34 divided by 2, you get 17. So our Q1 is 17. Are we okay with that, Mrs. Enala? We're just
Sorry, sir.
we're just dividing this data into parts. That's all that's happening here. Just dividing the data into equal parts. And we're just locating positions. That's all.
Okay.
Any questions before we find Q3?
Yes, sir. On our formula here, there is n plus 1 and p divided by 100. Why is it that p is 25 and n is 25?
P represents the 25th percentile. N, remember, it represents the number of numbers in this data set. N is the number of data values in the data set. Basically, the number of numbers in this data set. Okay, so with the 25th percentile, P is also going to equal 25. Remember, with the median here, the 50th percentile P was 50, right? Now, in this case, P is going to be 25. And as we'll see with the Q3, P is going to become 75 because it's the 75th percentile.
Excuse me, sir.
Yes?
Does it mean that every time you have the 50th percentile, it's always called Q2 and Q1 is always 25?
Yes. Do you remember when we were finding cumulative? Do you remember when we were finding cumulative frequencies, when we total up the data, all right? When we total up the data, okay, like here, we've totaled up the data to 875, all right? So you can find the median of that whole data by just finding 50% of 825. That will give you the 50th percentile, which is the middle position. All right. So Q2 is always 50th percentile. Q1, 25th percentile. Q3, 75th percentile. It's standard, right? Always Q2 is the 50th, Q1, 25th, and Q3, the 75th percentile. Always. Okay, there will never be time Q2 will be 25. No. Or these interchange, right?
So do you also have Q4, like for the full?
No, no. Quartiles, as I said, the main thing is to divide the data into 4 equal parts. So you always just be dealing with Q1 up to Q3. That's all.
All right, thank you.
All right. Okay, so next is Q3, this 75th percentile. Q3, Q3 is the, what do you call this? The 75th percentile. Meaning, percentile. Right, so we are now dealing with this green side of the dot. All right, we're dealing with the green side of the dot. Okay, so n plus 1 times p. Okay, so in this case p is going to be 75. N is 25 plus 1 times 75 divided by 100. All right, so 26 times 75. Right.
Thank you.
26 times 75 is 1950 divided by 100. The 19.5th position. The 19.5th position. So you start again counting from here. What? So this was our middle was the what position again? This was the 13th position. 37 was the 13th. So 14, 15, 16, 17, 18, 19. All right. So in between here, between 52 and 54. One, two, three, four, five. This side, 1, 2, 3, 4, 5. Yes. All right. Are we okay with that?
Yeah.
All right. So to get Q3 is going to be equal to 52 plus 54 divided by 2. Right. I believe that will give us 53. Right, that's 106 divided by 2. 106 divided by 2, 53. Right, so Q3 equals 53. And you can now get your quartile range, your interquartile range. Right, IQR, which is the interquartile range, IQR equals Q3 Q3 minus Q1. Okay, so Q3, what was our Q3? Q3 was is 53. 53 minus Q1 is 17. 53 minus 17, what do we get?
86.
If you're told to find the semi-interquartile range, the semi-interquartile range, semi-IQR equals 1 over 2 open brackets Q3 minus Q1. Right, so basically you just have to find what is half of the interquartile range. Right, so we're going to say that will be equal to half divided by 36. And what's half divided by 36? 18. Should I be 18? If they tell us to find our coefficient of variation, which is just a ratio, okay, the coefficient of variation is just a ratio of the standard deviation and the mean, right? This is just a ratio. Standard deviation. Let me just check the formula table to confirm. Yes, the standard deviation over the mean. Okay, that is coefficient of variation just a ratio which is expressed as a percentage. Our standard deviation, I remember, was what, 20.04? Was that? Am I correct? 20.04? Maybe I need to.
Yeah.
Yes, 20 point. And our mean, what was our mean? 35. So 20.04 divided by 35 times 100. Okay. 20.04 divided by 35 times 100. You get 57.2%. And we are done with the question.